Okay, so like I said, we are going to start off by reviewing what we learned last time because we're just going to be doing more of the same thing. We're just going to be switching up some of the calculations. But let's take a look at number 5, just to refresh our memories, okay? So in this problem, it's asking what is the molarity? So that means that we're looking for capital M, right? So in this problem, we are going to be looking for molarity, so we're looking for capital M, okay? Okay, and we're looking for the molarity of sugar, and this is the chemical equation for sugar, in 1 can, which is 330 milliliters of Sprite. So I have the nutrition facts for Sprite right here. So hopefully you guys are able to interpret it. So if you guys take a look at the nutrition facts, how much sugar is in 1 can of Sprite? Is that kind of hard to see? 38. Yeah, 38 grams. It's right here. So let's jot that down on our paper. So there are 38 grams of sugar, which is C12H22O11. There are 38 grams of sugar in 1 can of Sprite. Okay, so we're just going to jot that down because these are the numbers that we are working with. We got 38 grams of sugar, and we also know that 1 can of Sprite is 330 milliliters. So these are the two numbers that we're going to work with. Okay. So far, so good? Okay, so one thing that we learned last time is if you ever see milliliters, we got to turn it into liters, right? So what we're going to do is we're going to divide this number by 1,000. So I'm going to give you guys 15 seconds to pull out your calculator. See if you guys can find how many liters are in 330 milliliters. So pull out your calculator. See if you guys can punch that in. See if you guys can turn 330 milliliters into liters. Okay, so for your calculations, you should have done 330 divided by 1,000, and that will give you an answer of 0.33. So 330 milliliters is equal to 0.33 liters. Okay, so for the problems, make sure that if you ever see milliliters, the first thing you want to do is turn it into liters. Okay. Alrighty, guys. So since we are looking for molarity right here, we need to plug these two numbers into the equation, right? So we just found liters. So what number should we put on the bottom of this fraction? Yeah, 0.33 exactly. So I'm just going to erase it. Actually, let's not erase it. We'll do equals. We'll do equals 0.33 liters on the bottom. Okay. And now all we got to do is figure out what to put on the top right here, and that will allow us to solve the problem. Okay. Okay, so what we want to do now is we want to turn this other number, the other number that we didn't use yet, 38 grams, into moles, because we need to put moles on top of this fraction, right? Now, if you guys remember from last time, whenever we're trying to turn grams into moles, does anyone remember what we need to use? Yeah, exactly. We want to use molar mass. Good memory. Okay, so whenever you want to turn grams into moles, you want to use the molar mass. Basically, you go on the periodic table and you want to look up how much each of the elements weigh. And then after that, that's where you get your molar mass. So this one's a kind of a big molecule, C12H22O11. So let's see if you guys can do this on your own. So I'm going to give you guys, I'll give you guys about 2 minutes. See if you guys can pull out your periodic table and figure out the molar mass of sugar. I have the formula for you right here. See if you guys can use your calculator and periodic table to do that, okay? So take 2 minutes. Okay, guys, let's go over the molar mass of sugar. So I'm going to pull out my periodic table, which you guys should have as well. Now, sugar is made out of carbon. What's the molar mass of carbon? Yeah, 12.01. So we can write that down on our paper. 12.01. Okay, if we take a look at hydrogen on the periodic table, what's the molar mass of hydrogen? Yeah, 1.01. So let's write that down. So 1.01. Okay, and then lastly, we're going to look at oxygen. And what's the molar mass of oxygen? Yeah, 16. So let's jot that down. Okay, so now what we got to do is we need to multiply these numbers, because if you look at it, we don't just have one of each of the elements, right? So carbon has a 12 behind it, which means there are 12 carbons. So what we have to do is we need to take the molar mass of carbon and multiply it by 12. So all we're going to do is do 12.01 times 12. And so all of the carbons inside a sugar, they're going to weigh 144.12 grams per mole. Okay? And the reason why is because there are 12 carbons. Okay, it applies to the number in the front. Okay. All right, next one is hydrogen, and there are 22 hydrogens inside of sugar. So all we got to do is do 1.01 times 22. That'll give us 22.22. So all of the hydrogens are going to weigh 22.22. And we'll be adding these numbers up. Okay, and then last but not least, we got oxygen, which is 16, and there are 11 of them. So that's going to be 176. So if we put all those numbers together, that's going to give us the molar mass of sugar. Okay, so I know this is a bigger molecule, but we've been doing molar mass for a while, so hopefully you guys are okay with working with this. Okay, so if we add them together, 144.12 plus 22.22 plus 176, and that will give us a molar mass of 342.34 grams in 1 mole. Okay, if you got 342, that's fine. As long as you got something close to that, you're good. Okay, so if you got 342, 342.3, 342.34, anything close to that value is okay. Okay. Alrighty, any questions on the molar mass part? All right, so now we're going to use this number and we're going to turn the grams right here into moles. So what we're going to do is we're going to set up a fraction. So let's take this number right here, okay, 38 grams. And we are going to set up a fraction to turn the grams into moles, okay? I want to get rid of grams. So whenever you want to get rid of something, you put it on the bottom of the fraction. And then we're going to put what we're looking for on the top. So you're going to put grams on the bottom and moles on the top, okay? So we have the molar mass, and we got 342 on next to grams. So where should we put 342 on this fraction? Top or bottom? Yeah, bottom. We want to put it next to grams. Okay, and the reason why is because 342 is next to G, so we just want to put it next to G. And on the other side of the fraction, it's 1 mole, so we put 1 mole on the top. Okay. And so from there, pretty easy calculation. We just need to do 38 divided by 342.34. Remember, divide by the numbers on the bottom, and we should get a value of 0.1. And I'm just going to round it to 0.11 moles. Okay, so that's how you turn grams into moles. Okay, so now that we found moles, we can plug it into this equation and then we'll be all done. Okay, so we found that it's 0.11 moles, so we just put it on the top of the fraction. And then from there, we just need to do top divided by bottom. So 0.11 divided by 0.33. And then we'll get our final answer. And it's going to be 0. And you can just give me 2 numbers after the decimal, 0.33. And it's going to be molarity. And let's just write sugar, because that's what the chemical is. So this is your final answer right here in the box. Okay. All right, so that's review from last time. That's what we learned how to do. When you got grams, and you got to always turn it into moles before you could turn it into molarity. Okay. All right, so today what we're going to be doing is basically the same thing, but we're going to be going in different directions. So you see how we started with grams and milliliters to find molarity. Sometimes you'll get problems where you have molarity and a variable, and you got to find a different variable. So I'm going to be teaching you how to do that. It's basically the same thing that we learned. It's just we're changing up the math a little bit, but it should be stuff that you are familiar with. Okay, so we're actually only going to do one more practice problem together. But do you guys have any questions before we move on? Guys chilling? Okay, so we'll just go right to the very end. We'll do number 11, and this will be the last problem that we do, okay? Okay, so let's go over number 11, and then I'll get you guys started on your assignment. So here, this problem's a little bit different because this time we have molarity, right? Last time we were looking for molarity. This time I give molarity to you. Okay, so what that means is we're not going to be looking for molarity. We're going to be looking for something else. Okay, so if we read the question, it tells us that we have 5 grams of NaCl. So this is probably going to be important since it's a number. And we want to make a 0.75 molarity solution. Okay, and we are looking for the final volume. So in this problem, we are looking for volume. Okay, so does anyone remember, how do we measure volume in solutions? Do we use grams? Do we use moles? Do we use liters? What do we use to find volume? Okay, seems like people forgot, but we always look for liters. So jot this down if you guys didn't know that. Whenever you're looking for volume, you are always looking for liters, okay? Always looking for liters. All right, so we know from our equation that molarity is equal to moles divided by liters, which means this is what we're looking for right here. We are looking for L, okay? Okay, so what we want to do then is we just want to plug in these other two numbers, and that will allow us to solve for L, okay? So we have the number for molarity. What's the molarity in this problem? Yeah, 0.75. It's right here. So all we have to do is just put 0.75 for molarity right here. I'm going to rewrite that just so it's a little bit neater. Okay, we're going to write 0.75 molarity. Now, if we're looking for liters, that means we need to find moles right here, right? Okay, but the problem is, if you look at the problem, we don't have moles, we have grams, right? And so if you guys remember in the problem we just did, how do we go from grams to moles? Yeah, exactly, molar mass. Okay, so we want to do the same thing that we just did in the previous problem. We just have a different chemical right here. Okay, so I'm going to give you guys about 2 minutes. See if you guys can find the molar mass of the chemical that we're working with. Remember, this is NaCl. Okay, we never use I. It's not Ci. I had some people in my previous classes still using I, but we never use I in this class. All right, so take about 2 minutes. See if you guys can find the molar mass of NaCl. If you guys think you could finish the rest of the problem from here, please feel free to go ahead if you find the molar mass quickly. But I'm going to give you 2 minutes to find the molar mass of NaCl, and then we'll finish up the rest of the problem, okay? Okay, so NaCl, if we go on the periodic table, let's start with Na. Na is 22.99, so we can just write 22.99. And then if we go to Cl, Cl is 35.45. So we can just add those two together, and that will give us the molar mass of NaCl. So Na is 22.99, and Cl is 35.45. This one's a lot easier because we don't need a multiply or anything like that, but that should give us a final answer. We'll just make sure that we get the same one. Okay, of 58.44. So the molar mass is going to be 58.44 grams per 1 mole. Okay. All right, so what we're going to do now is we're going to take our 5 grams of NaCl, 5 grams of NaCl, and we're going to multiply that by the molar mass. So if you guys remember, we want to get rid of grams. So we put grams on the bottom, right? And then we're going to put moles on the top. Okay, so we're going to use the numbers here. So where should we put the 58.44? Top or bottom? Yeah, bottom, because it's next to G, right? We want to keep it next to G. So 58.44. And then 1 on the top, and that will allow us to find how many moles we have. Okay, so 5 divided by 58.44, and that will give us a final answer of 0.0, and let's do 85. Thanks, ladies. Okay, so that's going to be what we have for moles. Okay. All right, so what we're going to do now is we're just going to plug it into this equation right here. So let's put this number on the top, 0.085. And then we can solve for liters. All right, now, depending on how comfortable you are with algebra, this might be a very easy problem. You just need to isolate the liters. But I've noticed a lot of people have trouble when the variable you're looking for is on the bottom. So I'm just going to tell you guys a quick trick that you guys can use. When you guys are looking for the volume, and this only works when you're looking for volume, okay? When you're looking for volume, what you can do is you can just switch molarity and liters, and that will give you the correct answer, okay? So we can set up the equation so it looks like this. Okay, you can just switch positions between liters and molarity, and that will allow you to solve for liters in one step, okay? So again, this only works when you guys are solving for liters, okay? But just make sure you guys, if you guys aren't comfortable with the algebra, you guys can just use this, okay? And for those of you that are interested, it's because you want to multiply by liters on both sides, and then you're going to divide by 0.75 on both sides, and that's how it ends up on the bottom. But if the algebra part is a little bit tricky for you, that's all good. That's why I'm going over the little trick you can use. Just switch molarity and liters, okay? All right. And if we do that, it's a very quick and easy solution. All we got to do is 0.085 on the top divided by 0.75 on the bottom, and that will give you your final answer, which is 0.11 liters. That's it. Okay, so if you guys notice for this problem, it's very similar to what we've been doing. We're just looking for something else, right? The first problem we did, we were looking for capital M. This time we're looking for L. And so in this problem, you'll be just switching up what you are looking for part 2, okay? All right, but other than that, that's going to be it for today. I will give you guys the rest of the class period to finish up the assignment part 2. So you guys got to make sure that you guys have part 1 and part 2 done for the molarity assignment before you turn it in, okay? I'll leave this up here for you, and I have recorded this, so it will be posted on Canvas if you guys need a refresher. And I'm here to help you, and I got the answer key available if you guys want to check your answers at any point, okay? Other than that, I'll give you the rest of the class period of work, and let me know if you guys got any questions, all right?